Hello everyone, welcome back to the channel. So here's something that happens a lot with APIs. Everything feels smooth, fast, no issues at all. And then suddenly it just stops working. You try again, same thing, and then you notice too many requests. And your first reaction is usually, wait, what did I even do? Because from your side it feels normal. You clicked once, maybe refresh twice, nothing's crazy. But from the system side, it's a very different picture altogether. So let's actually understand what's going on behind the systems. Let's see a basic flow. Every time you click something, this flow kicks in. Your request goes to the API, then to the service, then to the database, and the response comes back. This whole thing happens in milliseconds, so fast that you never really think about it. But speed does not mean the system can handle anything you throw at it. Let's suppose I increase the number of users. Let's see, I can increase 100 users more. Now, imagine 100 users are doing the exact same thing at the same time. That's when things starts getting interesting. Because every system has limits, right? There is only so much CPUs, memory, database capacity available, not much enough to handle a lot of users. The load increases, the request also increases, the response times also increases. So it goes in the flow. As more requests comes in, system starts getting slow eventually. Now, here's where things get tricky. When response slows down, users tends to retry, sometimes manually, sometimes automatically. So now one request quietly turns into multiple requests and that increase the load even more. This is how system starts getting overwhelmed. So there is one more alternative as well, queue. Sometimes instead of rejecting requests, systems delay them. So let's suppose the user has 20 requests per second like we discussed. Now instead of blocking them, it can move those requests into a queue like we have here. Requests are placed in a queue and processed one by one by the worker to the service. This works well when immediate response aren't critical, like background jobs or notifications. But for real-time actions, delays can feel like system is broken. There is one more concept which can come in is cache to reduce the load basically. So let's suppose I have the user with me. I can have a cache system and my response, and I have my API. So here's cache can help in. This is one way systems reduce loads by offloading repeated work. Instead of recomputing or refetching the same data, they serve it from a faster layer. A very common real example is a product listing API. Let's say I have 10,000 users opens the same homepage. Without cache, that 10,000 database calls. With cache, it might be just one DB call and the rest are served instantly. That's a massive difference, right? Technically, this is usually done using systems like in-memory stores like Redis or distributed caches because memory access is much faster than hitting a database. Another important detail would be cache is often placed at very close to the API layer, so the request gets resolved earlier before it even reaches the deeper parts of the system. And in high scale systems, this becomes very critical because databases are usually the most expensive and sensitive resource. So the goal is simple, hit the database as little as possible. Over the time, cache ends up handling most of the read traffic, which means the system can scale much better without increasing database load. It's not about just handling more requests, it's about doing less work per request, which is important in case of rate limiting concept as well. Now, let's look at how this plays out in a real system. Think about ticket booking during a big release. Everyone clicks at the same moment without any control. All those requests could hit the system at once. That leads to a database overload, conflicting updates, and failures. With rate limiting, only a controlled number of requests are allowed through. The system stays stable even under the high traffic. So this is one of the example real world which can be implemented using rate limiter. There are one more examples like public API abuse. So suppose I have multiple users A, B, C, right? A, B are sending requests within the request limit reach, right? But the C user is sending 100 requests per seconds again and again. So what will happen? But without any limits, that single user could consume most of the system resources. So rate limiting ensures that each user gets a fair share. Normal users continue without issues, and excessive usage gets restricted. So that C user will get a restrictions on the API hits. So when you look at a full system overview, whatever we have drawn till now, you can understand few things. So, when you look at the full system, rate limiting is just one piece of the puzzle. It works along with caching, queuing, and efficient processing. All of this together helps the system stay stable under the load. So, the next time you see too many requests, don't assume something is broken. It just means the system is under pressure and it's handling the right way. If this made sense, consider subscribing. We are building this step by step. See you in the next one. Thank you for watching this video.